Okay, girls, exercise 8.6, tangents and normals. Now, you know what a tangent to a curve is. It looks like this, like where it only touches the curve at one point. So this line here is a tangent. Oops. So if you've got a curve there, that's a tangent, touches the curve at one point. Then there's a mistake there. Oh, that's a 5. 2x to the 5. Thank you. That's a 5. Right, so there's a tangent, and I'm going to draw a normal now in another colour. Here. In pink. The tangent is in black. Here's the normal. The normal is in pink. So the normal is what? Perpendicular to the tangent. So I better put this down here. So I've got that the normal to a curve, you might want to put this at the top before we start. So the normal to a curve is perpendicular to the tangent. So, okay, yeah, it's C. So we'll need some notes first. You might want to put this little, here's the little box, a bit messy. So what is, we know what a tangent to a curve is. It's the line that touches the curve at only one point. And the normal to a curve is perpendicular to the tangent. So before you can find the normal, you have to find the tangent, or you've got to find the gradient of the tangent. So how do you find the gradient? So the steps would be, sorry about all these lines, how do you find the gradient of the tangent? So here, yeah, so to find the gradient of the tangent, this is what we do. We find dy dx, we differentiate and sub in the x value at that point. So these are how you do it. So to find the gradient of the tangent, you differentiate. You know how we did all those investigations where we looked at the gradient to the curve? Well, differentiating the curve gives you the gradient function, and then you just substitute your value of x to find the gradient, let's say at this point, or we want the gradient at that point, or the gradient at this other point. Sorry, you can't see that. Or the gradient at some other point. So you've got your gradient function, then you substitute in an x value, because look, the gradient of the tangent changes all the time on your curve. So you substitute in the x value at that particular point to get the gradient of the tangent at that point. Does it make sense? Then, so to find the gradient of the tangent, you differentiate, find dy dx, and sub in the x value at that point. But to find the gradient of the normal, what do you do? Yeah, we flip the gradient. We do the negative reciprocal of the tangent. We use m1 times m2 is -1. In other words, if I put that the gradient of the normal, you know, m is the gradient, symbol for gradient. So the gradient of the normal is -1 over the gradient of the tangent. You know how we just, if you know the gradient of the tangent, you'll flip it and put a negative in front of it, and that will give you the gradient of the normal. Or you can use m1 times m2 is -1. I don't like using that. I just like to get the gradient of the tangent, flip it, and put a negative in front of it. Are we okay with that? So girls, gradient of tangent, we'll just come back up here, is where we differentiate and substitute in an x value. So if you want to find the gradient of the normal, you've got to find the gradient of the tangent first, and then flip your answer for your gradient and put a negative in front of it to get the gradient of the normal. Okay? Then, that's that. So, are we okay? Sorry about my mess. All right, what we'll do, we'll just do that example first, okay? And then we'll look at equation of tangent and normal. From there, once you've got the gradient and a point, we just use point gradient formula for equation. All right? So, all right, let's do question C. We want, this is question 3C from your textbook. We want, so question 3C, find the gradient of the tangent and the gradient of the normal to this curve. So the curve is y equals 2x to the power of 5 minus 7x squared plus 4. That's my curve. So we want the gradient of the tangent and the gradient of the normal to the curve at the point where x equals -1. Okay? So you got that question up there? All right. So are we ready? So what do I do? dy dx is 2 times 5x to the 4, which is? All right. So you'll be able to start writing them straight out. 7 times 2x and then plus 0, which we don't do. I'll just put the plus 0 while we're learning. 10x to the power of 4 minus 14x. Girls, that's the gradient function. So, when x equals -1, dy dx is, so do you know why I'm substituting x is -1? Because I want the gradient of the tangent where x equals -1. There's my function. There's my gradient function. Now, the gradient function gives me the gradient of the curve at any point I choose. So I'm wanting the gradient of the tangent to the curve, when x equals -1. So I say when x equals -1, dy dx is 10 times -1 to the power of 4 minus 14 times -1, which is? No, it's positive 10 actually. 10 plus 14 is 24. So I'm going to say, therefore, the gradient, need to make a little conclusion, of the tangent at x equals -1 is 24. It's pretty steep, in other words. Positive 24 is a big gradient. 24 means 24 over 1. You're rising 24 for every running of 1 across. So the gradient is very steep at that point, okay? Now, therefore, the gradient of the normal, so that's the gradient of the tangent, that was part 1. Part 2 is asking you for the gradient of the normal at x equals -1. So it's just, you know how 24 is 24 over 1? It's -1 over 24. It's just flipping. So you're taking the 24 over 1. That's the gradient of tangent. Just down here. If that's your gradient of tangent, you're flipping it upside down and making it 1 over 24 and putting a negative. So this is the negative reciprocal. So gradient of tangent is 24 when x equals -1. So you have to have substituted and found the gradient of the tangent first. Not just the gradient function, you've got to do the substitution of your x value first, get the gradient of the tangent, and then just flip it and put a negative. Find the negative reciprocal. Okay? All right, we're now going to do another question, just taking this one step further. Okay, we're now doing one extra step where we're finding the equation of the tangent to the curve. Now, this is v equals 4t to the power of 4 minus 7t cubed minus 2 at the point where t equals 4. Girls, the v is in place of where you'd normally see the y, and the t is in place of where you'd normally see the x. So instead of writing dy dx, what do we write? dv dt. Okay? Now I'm picking these on purpose so that you get used to changing the notation. So we want the equation of the tangent to the curve. So tangent, you know, automatically you have to do the differentiate. So you've got 4t to the 4. So you might write out the normal function first. I like to do that. Then you write dv dt is, what do you get? So 16, 4 times 4t cubed is 16t3 minus 21t squared plus 0. So we don't need the plus 0. So when t equals 2, dv dt is, so that's the gradient. Oh yeah, squared, thank you. Fix that 2, that's a 2. Okay, so anyone got, okay, that's a 2 there. Okay, so when t equals 2, dv dt is 16 times 2 cubed minus 21 times 2 squared, which is 16 times 8. Well, it's less than 160. 160 minus 32. 128. Minus 21 times 4. Minus 84. 40. Yeah? Is it 44? So, girls, that's another very steep curve. When t equals 2, the gradient is 44. Now, I want so whatever my curve looks like, and it probably looks like, this is a T4, x to the power of 4 type thing, it probably looks like this, all right? Right, when t is 2, it's probably up here somewhere, this, or it could be somewhere else, I don't know. But I'm not sure exactly where it is, but it's very steep. The tangent's very steep. Girls, I need to find the equation. So I've got that my gradient is 44 on my curve. Be very careful here. I might have that the gradient at this point is 44, but I need a point on the curve. I've only got the t value. Where do I substitute t equals 2 into? The differentiated function or the original? So I need to find the y value or the v value of the original function. See, I've got here, if this is my curve and this is my gradient, I know here that t is 2, but I need the y value of the curve. So I have to sub t equals 2 into v equals 4t to the 4 minus 7t cubed minus 2, because I need a point on the original curve. So it's 4 times 16 minus 7 times 8 minus 2. Anyone got 32 minus 42 minus 2? 32 minus 56 minus... Oh, yeah. What is it? Okay, so the point on the curve is 2, 6. You're telling me you're getting 6 here? Yeah. All right, so this point on the curve is 2, 6. Do you get that, girls? Yeah. See, I know the gradient at this point is 44. And I need a point on the curve. When you find the equation of a line, you need a point on that line and the gradient. Okay? So you only substitute into the derivative, dv dt, to get the gradient, not to get a point on the curve. If you want a point on the curve, you substitute into the original curve. Okay? So now, therefore, the equation of the tangent, so we're going to use that point and gradient 44, is equation of tangent is y minus y1 equals mx minus x1. So it's y minus 6 equals 44x minus 2. Y minus 6 is 44x minus 88. Look, I don't mind this in y equals mx plus b form because there's no fractions. Bring the plus 6 minus 82. Or it may be written as 44x minus y minus 82 equals 0. So that's y equals mx plus b form. General form, keeping the x positive, would be written like that. Okay, so you've got both forms. So, oh yeah, no y's and x's. All right, so now just stop for a sec. I know we did this, so now what do? We replace so thank you. You replace, you know how I said the v is in place of the y and the t? Yeah. So we go v equals 44t minus 82, or 44t minus v minus 82 equals 0. Okay? Because we know that we've got a direct replacement of the y with the v and the x is replaced with the t. So just do that last. I wouldn't do that here and try and do that here. You'll get into such a big mess. I wouldn't be writing v minus v1. Just do that because you're used to it, and then just swap it at the very end, and that's fine. Okay? Now, we're going to find the equation of the normal. So it'll be very similar. One extra step of flipping the tangent and doing the negative reciprocal of the tangent. So we're going to do question, I'll just turn over the page. Oh no, I should fit it. So question 5. So sometimes they give you the point and other times they don't give you the point. I'm going to do question 5C. to find the equation of the normal to the curve function of x equals 7x minus 2x squared at the point where x equals 6. Now you might decide to, before you even start doing all this derivative stuff, why don't you work out when x is 6 what the y value is? You might want to do that first if you want. Do you know what I mean? You know what I'm saying? So you could just work it out over the side. You just say when x is 6, let's just get that point on the curve before we start. Function of x, or the y value, is, do you know what I'm doing here? I need that point on the curve. It's 7 times 6 minus 2 times 6 squared. 42 minus 72. Is it negative 30?
Yes.
So the point on the curve, see, it says find the equation of the normal to that curve at the point where x is 6. That point on the curve is 6, negative 30. See, some questions already give you the point, okay? So it may be a good idea to work out that point first. So now it becomes find the equation of the normal to that curve at the point 6, negative 30, okay? So let's get to business over here now. We're going to keep with the notation. When you've got function of x, if you want to do the derivative, we don't write dy dx. What do we write? F dashed x. All right? If you're given the equation in y, you can write y dash or dy dx. If you're given the equation as function of x, you write it as, the next step down, f dashed x. All right? So f dashed x is what? Differentiating 7x, what do you get? 7. No, only a constant. You just drop 1 power of x down because you're bringing, all right, minus 4x because it's 2 times 2x. So what do I do next? So that's my original curve, function of x. F dashed x is my gradient function. So now I say when, I need that's the gradient function, but I need the gradient when x is. So when x is 6, I'm just going to go gradient of the tangent is 7 minus 4 times 6. 7 minus 24 is negative 17, but I don't want that. So then I go gradient of the normal. Are we okay? It's flip it, because that's negative 17 over 1. So I flip it and put a negative, or just do the negative reciprocal. Negative and negative is now positive. So the gradient of the tangent is negative 17, which is negative 17 over 1. Flipping that and putting another negative, or taking that one away, you get the gradient of the normal is 1 over 17. So now, therefore, the equation of the normal is y minus y1 equals m bracket x minus x1. Now I'm just going to go over the page. So we've got, there's our point up there. So there's the point. So we're going to use 0.6 negative 30. We're going to use gradient 1 on 17. So that's what we're using. They're circled up here. So we go y minus negative 30 is 1 over 17 x minus 6. So you know this 1 over 7, you know this 17, it's best to put it over this side straight away. I wouldn't be multiplying through by, you know, if you think this really, or I can write it like this, y plus 30, isn't that 17 on the denominator? You can write it like this. Do you agree? So now put that 17 in front, multiply the other side by 17. It's much better. Okay? Equals x minus 6. So I think it's easier, all right? Which gives us 17y plus
510
equals x minus 6. Now, we're going to put that into, whenever you've got a fraction here, go for the general form, ax plus by plus c equals 0. If you don't have a fraction here, it's fine to put it into y equals mx plus b form, unless they're asking for general form. Okay, but whenever you've got a fraction here, it's best to put it into general form. Keeping the x positive, you get x minus 17y minus 516 equals 0. So that's the equation of the normal, okay? So 7x minus 2x squared is a concave down parabola, all right? And when x is 6, the gradient would be, I could sketch it, but I don't think I will. Actually, I can do a quick sketch. If you've got y equals 7x minus 2x squared, girls, how would you sketch it? What would you do first? Factorise. X bracket 7 minus 2x. So where are the intercepts? 0 and 7 on 2, I think. 3.5. Concave up or down? So this is what it looks like. This is good enough. This is the point 7 on 2, that's 0. You need the gradient. This is what we're doing. So that's the curve. We're just doing a quick sketch so you see it. You've got the point 6, negative 30, which is down here somewhere. This is the tangent. Got that in pink. Okay with that? This is the point 6, negative 30. You know how we had that point? This is the normal. Got that? See, pink is the tangent. The black one is the normal. And have a look at if it was in y equals mx plus b format, but it's not. You'd have a y-intercept negative something. No, notice this hasn't been drawn to scale. It would be whatever 516 over 17 is. 30-something, negative 30-something, which looks right. Okay? And the gradient is positive. I can tell from here. The gradient's 1 on 17. I can actually tell from here. Look, if I make it plus 30 and take it over, the gradient's 1 on 17. So it's actually meant to be a bit flatter than that, but that's just a sketch that I've drawn. So the tangent is in pink. Got the idea? And see why we needed that point on the curve, 6, negative 30. Tangent has got the gradient of negative 17. And it passes through 6, negative 30. And the normal had the gradient of 1 on 17, and it passed through 6, negative 30. Okay, another question. We're looking at question 9. A function of x equals x squared plus 4x minus 12 has a tangent with a gradient of negative 6 at point P on the curve. Find the coordinates of P. Be careful here. We're told that the gradient of the tangent at a particular point is negative 6. So you'll know that you need to differentiate because they're talking about gradient of tangent, but you don't then substitute x equals negative 6. You actually know that when you do your substitution of x, your answer is going to be negative 6. So we're actually being asked this question in the reverse way to what we've been asked before. Okay, girls, take a guess somewhere on this curve. Do you think that point's going to be over here to get a negative gradient or over here? I reckon it's going to be over there. I reckon it's around here somewhere. I don't think that's steep enough down here. See, this is negative gradient, but not very steep. This is a steeper negative gradient. It's going to be here somewhere. We're expecting a negative value of x for our answer. All right, see here, positive gradient. We're looking, where's the gradient negative 6 on this curve? Because it's gradient of tangent, so let's write down the function first. What do we do first? And how do we write it? F dashed x is 2x plus 4. Now we know that we want to find x when f dashed x is what? See, we're told that the gradient of the tangent at a particular point is negative 6. So gradient of tangent is the f dashed x. We're told that the f dashed x is negative 6. You have to sub f dashed x into, negative 6 into the f dashed x here. All right, so we go negative 6 equals 2x plus 4. So 2x is negative 10. So x is negative 5. So it's actually down here somewhere. I obviously haven't drawn it very well. Any colour. So girls, okay, we still haven't found the point, but I'm just showing you, they're saying it's somewhere here. Obviously, my curve is not drawn to scale. So you know how it cuts through at 2, negative 6? This might be the point where x is negative 5 here. I don't know the point on the curve. I just know that's -6. How do I find the point on the curve? So I sub x equals -5 into what? Into the actual curve. If they want a point on the curve, you substitute it into the curve, not into the gradient function, into the curve. So I get function of x is, remember function of x just means it's the y value, by the way. And what do you get? 25 minus 20 minus 12, negative what? So therefore this point, obviously my graph is pretty bad. It's -5, -7 is my point P on the curve. So obviously this curve should be a lot steeper. And if I look at the y-intercept, it's -12, so it's actually really more like this. And even that is still not, because you know the axis of symmetry will be halfway between the -6 and the 2, which will be +2, -2, sorry. And this is probably quite low, this vertex. I could find the vertex if I wanted, but they're saying that the gradient, and that's not drawn very well. All right. See, parabolas are more like this. Do you know what I mean? Yeah. So my curve's not drawn very well, but it's probably down here somewhere. Like that. So they're saying the gradient of this line is -6 at the point -5, -7. A bit not drawn very well, but good enough. Okay, we'll look at another question.